Welcome friends. Today's video lecture will be about carbon cycle. Carbon cycle. In our previous lecture, we discussed introduction of nutrient cycles. I told you that nutrient cycles are of two types, right? One, gaseous nutrient cycles, and sedimentary nutrient cycles, right? I told you that gaseous nutrient cycles are carbon cycle is a gaseous neutral cycle, hydrogen cycle is a gaseous neutral cycle, nitrogen and oxygen, right? And in sedimentary cycles, I told you phosphorus cycle, sulfur cycle, potassium cycle and calcium cycle, right? Now today we will discuss one gaseous cycle and we will try to discuss one sedimentary cycle, right? Let's go for carbon cycle today, right? Carbon cycle. As you know that carbon is almost present in every organic compound, whether this is carbohydrates, you can see carbon present in it, whether it is lipids, proteins, right? Nucleic acids, enzymes, hormones, whatever organic compounds we have, the carbon is the main component of these organic compounds. So we may say that carbon is the basis of life. We consider carbon as basis of life because all the organic compounds, organic substances which are present in living organisms are formed because of participation of carbon in their formation. So we consider carbon as basis of life. Right? So when I talk of life, it means that essential living component, biotic component of ecosystem. So carbon is so essential that we have to ensure its presence, right, in the ecosystem. Only then ecosystem will continue to move, continue to grow when there is sufficient and regular supply of carbon to the ecosystem, right? So we have to see how this carbon is essential for maintenance of life of living organisms, whether it is a plant or it is an animal, right? We have seen its importance. So when it gets incorporated into the organic compounds, which are the components, which are the building blocks of living organisms, from there, this carbon is to be released so that it can be again used, right? So it forms the basis of life, man. So it gets incorporated into the living organisms, right? And from living organisms, it is to be released so that it is reused again for biotic component of ecosystem to grow continuously without any break, right? If we will see the composition of living organisms, अगर हम कंपोजिशन देखेंगे लिविंग ऑर्गेनिज्म, कार्बन कॉन्स्टिट्यूट्स 49% of dry weight of living organism. When we study the composition of living organisms, we see that carbon constitutes 49% of dry weight of living organisms. What does this dry weight mean? When we remove all the water from the living organism, right? By drying, okay? We say that this is dry weight of living organism. And carbon constitutes 49% of dry weight of living organism, right? Now we have to see in a cycle, it is very necessary to see the source of carbon, right? Now let us discuss the sources of carbon. There may be many sources of carbon, such as number one, you can see carbon in air. When I say air, I mean atmosphere, right? This is one source of carbon. Second source of carbon is water. When I talk of water, this is oceanic water, water of oceans. These are two main sources of carbon. Atmosphere, I mean air, and oceans, I mean the water of oceans, right? In addition to these two sources, we can also find, carbon in fossil fuels, and some amount is also present in rocks. So these are four, sources of carbon. But these two, air and water, are the main sources of carbon, right? Let us come to the first one, air. The main source of carbon, air. In air, you can see carbon occurs in the form of carbon dioxide. It occurs in the form of carbon dioxide. If I will estimate the amount of carbon dioxide, there are 6 tons. If I will tell you, there are 6 tons of carbon in the form of 6 tons of carbon in the form of carbon dioxide in the atmosphere. In the form of carbon dioxide in the atmosphere in each acre of Earth's crust or Earth's surface. In each acre of Earth's surface. Right? I said that in atmosphere or in air, carbon occurs in the form of carbon dioxide. There are about 6 tons of carbon in the form of carbon dioxide in the atmosphere in each acre of Earth's surface. Right? From this atmosphere, this carbon dioxide, right, gets incorporated. It gets incorporated in the tissues of plants. In the form of carbohydrates. What does that mean? That means when plants, perform photosynthesis, right? This carbon dioxide gets incorporated into the tissues of plants, right? As carbohydrates. Why? Because of photosynthesis, carbon in carbon dioxide, right, gets converted into carbohydrate, right? This is the source of carbon in atmosphere. Now let us discuss second source, that is the oceanic, that means water, oceanic water, oceanic water. Air, atmosphere, and next source is the water. Okay? Carbon occurs in water. When I say water, oceanic water, either dissolved in it, it may be in water present, either in dissolved form or combined with water. The carbon in water may be present either dissolved in water or combined with water. When it combines with water, it forms carbonic acid. What it forms? Carbonic acid. Let's write down here. If this is carbon dioxide, it combines with water, it gives HCO3. Right? H2CO3, I'm sorry. H2CO3. This is carbonic acid. Right? Okay. This carbonic acid then gets dissociated. This carbonic acid then gets dissociated into hydrogen ions, right, and bicarbonate ions. These are the bicarbonate ions. You see, these are bicarbonate ions. Are you getting me? Bicarbonate ions. These bicarbonate ions, now we have bicarbonate ions. These bicarbonate ions dissolved in water, these bicarbonate ions dissolved in water are taken up by aquatic plants, to perform photosynthesis. Right? I said that in water, oceanic water, carbon in the form of carbon dioxide may be either dissolved in water or it may combine with water. Right? When it combines with water, it forms carbonic acid. Okay? This carbonic acid dissociates to form hydrogen ions and bicarbonate ions. Now these bicarbonate ions dissolved in water, these are taken up by aquatic plants so that these aquatic plants perform photosynthesis. Right? If we estimate the global, quantity of carbon, if we estimate the global quantity of carbon, we find global quantity. The total amount of carbon found in this globe. Okay? We found that 71% of carbon is found in 71% of carbon is found in dissolved oceans, is found dissolved in oceans. I mean, maximum of carbon we will find in oceans. 71% of carbon, right, is found dissolved in oceans. And if I talk of atmosphere, you will be surprised to know that there is only 1% of carbon. 1% of global carbon. Global carbon, right? Found in atmosphere. If we will compare the carbon in water and atmosphere, there is a huge difference. 71% of carbon is found in oceans, dissolved in these oceans. While as compared to this, oceanic carbon, you can see only 1% of global carbon is found in, atmosphere. And I may tell you that 4 into 10 raised to the power 13 kgs of carbon are fixed. 4.10 raised to the power 13 kgs of carbon are fixed per year. Are fixed per year by green plants. Green plants during the process of photosynthesis. During the process of photosynthesis. Are you getting me? 4 into 10 raised to the power 13 kgs of carbon are fixed by green plants per year. Right? Producers, I may say here producers. Now what happens? Suppose this, we will see, just talk of how this occurs. Right? This is land area. Suppose this is land area. Right? Okay? And this is an ocean. This is an ocean. Right? There is oceanic water. There is huge quantity of, carbon dioxide. 71% of carbon dioxide. Right? And here there are phytoplanktons. Phytoplanktons are there. These phytoplanktons, right, start photosynthesis. Okay? When they start photosynthesis, now this carbon dioxide gets incorporated into the bodies of plants. Same thing starts to begin here also. Here on the land, there are also land plants. Okay? Are you getting me? Right? These are on the land. These are terrestrial plants. These also start, making use of carbon dioxide in the process of photosynthesis. When this photosynthesis takes place, carbon gets incorporated in the bodies of living organisms, particularly, in the first place in plants, in the form of carbohydrates, in the form of proteins, in the form of nucleic acids, in the form of enzymes, in the form of hormones. Now we have plants which have performed photosynthesis and they have incorporated, they have fixed carbon into their bodies. These plants are now eaten by herbivores. Herbivores. Right? Herbivores in turn are eaten by different types of carnivores. Different types of carnivores. Now this carbon has been incorporated into living organisms. Be it the plants or animals, herbivores, producers. From producers it went to the herbivores. From herbivores it went to the carnivores. Different types of carnivores. Now from these living organisms, it's to be released. What will happen? Ultimately, these producers, herbivores, are different types of carnivores. These will die. Right? And their dead bodies will be decomposed by microorganisms. Right? When their dead bodies will be decomposed by microorganisms, right? The individual components of their bodies, of their organic compounds, they will be released. And this carbon will be accordingly released. Is that clear to you? This is how it happens. But at the same time, here respiration also takes place. Some part of carbon which was, incorporated in the plant of, in the body of plants and animals will be quickly released because of respiration. In respiration what we do? We take in oxygen and we give out carbon dioxide. Same is the case with these plants, animals. They release carbon, some amount of carbon, very quickly in the form of carbon dioxide. Now it is available again, right? And this thing which I was telling you a bit earlier, I was telling you that in living organisms, death takes place. When they die, their dead bodies are acted upon by, microorganisms, right? Decomposition takes place. And by decomposition, they are, broken down and their components are released. And the component, I mean to say that carbon is also released. It may take some time. It takes time, right? But during respiration, a part of, this carbon is released quickly. Is released very quickly. It's the way how it whole thing takes place, right? Now, I also told you that third source is the fossil fuels. Fossil fuels, where you can find also carbon. Fossil fuels are formed from organisms, right? Which died in remote past, whether it was a plant, whether it was an animal, thousands of years, hundreds and thousands of years. These plants and animals died in remote past. When their dead parts undergo decomposition, then their dead bodies saw a impartial decomposition. Because of this incomplete decomposition, fossil fuels were formed. And when plant bodies, dead plant bodies, saw incomplete decomposition, coal was formed, right? And when animal bodies faced incomplete decomposition, petroleum and natural gas was formed. Petroleum and natural gas was formed. It's the reason we say that these are fossil fuels. I must say you again, fossil fuels were formed by organisms which died in remote past. The dead bodies of these plants and animals show incomplete decomposition. Because of incomplete deposition of plant dead debris, dead parts, coal was formed. And because of incomplete decomposition of animal bodies, natural gas and petroleum was formed. And it is said that these materials, such as coal, petroleum, natural gas, these possess or contain 50 times greater amount of carbon, which is locked in the bodies of living organisms, plants and animals. If I compare the amount of carbon present, which is locked, which is incorporated in the bodies of plants and animals, with the amount of carbon, quantity of carbon locked in petroleum, coal and natural gas, these show 50 times greater. I'm these show 50 times greater amount, right? And this is where these fossil fuels, also possess some amount of, this carbon. And now how carbon is released from fossil fuels, right? Carbon is released from fossil fuels. When we use these fossil fuels, right? When we burn them for different purposes, we burn them in automobiles, we burn them in factories, we burn them in powerhouses. This carbon is released into the atmosphere. This is how fossil fuels can release the carbon, right? And it is made available again for the reuse, for recycling. It's the reason why we call these type of things cycle, carbon cycle, hydrogen cycle, where there is continuous supply of this mineral element. Then I talked of another source, that is rocks, right? Rocks also possess these carbon dioxide, I may say. Rocks also possess carbon dioxide in the form of carbonates, right? In the form of limestone, right? And in the form of graphite, graphite. Right? And these carbonates are converted into carbon dioxide. In the rocks, these carbonates are converted into carbon dioxide by soil microorganisms. Right? These are converted into, carbon dioxide by soil microorganisms. How? Because these soil microorganisms secrete acids. These are the acids which convert carbonates into carbon dioxide. And even for that matter, you can see plant roots. Plant roots also secrete acids, different types of acids. And when these rocks begin to worn out, these rocks begin to break down, right? Then these carbonates present in rocks are converted into carbon, dioxide by the acids secreted by soil microorganisms and plant roots. And it's the way how this, carbon present in rocks is released. Right? This is how this whole cycle of carbon takes place. Now, sometimes human activities have influenced the carbon cycle because of excessive use of fossil fuels for energy production. More and more carbon dioxide is released into the atmosphere, which is very, harmful. There should be a optimum. There should not be a minimum or maximum kind of thing in the atmosphere. If we have carbon dioxide, it should be in an optimum, quantity. As a result, this whole cycle of carbon is influenced by such activities, human activities, excessive use of fossil fuels, right, for energy production, deforestation, you can say, right? And this influences the carbon cycle, and the amount of carbon in the form of carbon dioxide in atmosphere gets increased, as you have seen in greenhouse effect. I hope that you will have understood today, and hope that you will see my another video. Thank you.